Hi everyone. Today's presentation covers the loan default prediction model I built, and I'll be walking through how I handled pre-processing, class imbalance, model selection, hyperparameter tuning, fit assessment, and what I would do next to further improve the classifier. The dataset includes demographic and financial information about loan applicants. Our target variable is loan default, where 1 means the applicant defaulted. One challenge is that the classes are imbalanced. Only about 22% of applicants default, which can cause models to predict the majority class too often. And our overall goal is to maximize the F1 score because lenders care about both precision and recall. To prepare the data, I standardized all numerical features, including age, income, interest rate, and credit history length. This ensures that no feature dominates others because of scale. For categorical variables like education level, home ownership, and loan intent, I used one-hot coding. This creates clean binary indicators that allow tree-based models, especially XGBoost, to learn specific interactions like how loan purpose interacts with credit score. Overall, this pre-processing step dramatically improved model performance and interpretability. In this figure, you can see the top 10 most important features. The strongest predictor by far is whether the applicant had no previous defaults on file. Home ownership also matters significantly. Both owning and renting appear separately because of the one-hot coding. Loan intent categories like venture and home improvement also played a role. This confirms that our feature engineering approach was effective, especially expanding categorical variables into meaningful model-ready signals. I compared three main models. Logistic regression, which is simple and interpretable, but underfit the data with an F1 of around 0.74. Random forest, which captured more complexity and achieved around 0.81 F1, but was less stable across folds. XGBoost, which performed the best, consistently achieving around 0.84 F1 in cross-validation. The reason XGBoost works so well is that it handles nonlinear relationships, spares one-hot coded features, and class imbalance very effectively. I also explored Smote, but I found it increased overfitting for my code, which is common when applying synthetic sampling to tree-based models. The best approach for me was using XGBoost scale POS weight, which directly adjusts the loss function to give more importance to the minority class. I also tuned the decision threshold between 0.5 and 0.8. This was crucial because in a lending context, predicting too few defaults can result in major financial losses. By adjusting the threshold, I significantly boosted recall while still maintaining precision. I also tuned several key hyperparameters, which is the number of trees to 1200, the learning rate of 0.05, a maximum depth of 6, and the subsample ratio of 0.9. These reduced overfitting and improved generalization. Together, tuning added about 0.02 to the F1 score, which made a measurable improvement on the leaderboard. To ensure my model generalized well, I used 10-fold stratified cross-validation. This means the dataset is split into 10 folds, each preserving the default rate. I trained 10 separate XGBoost models and averaged their predictions. This ensemble approach stabilized performance and improved my F1 score. It also helped address variance and reduce the impact of any single noisy fold. Here is the learning curve generated for the model. It plots F1 score versus the number of training examples and helps diagnose underfitting or overfitting. And we can see that the training score differs much from the validation score, which is a more stable, but that's to be expected. And overall, the XGBoost model was able to lower that gap and make it smaller. We see that the training score is significantly higher than the validation score, which indicates some overfitting. This is expected for boosted tree models. However, the validation curve is fairly flat and stable as the training size increases, meaning the model generalizes well, and adding more data would not dramatically change performance. Using cross-validation, subsampling, and averaging across 10 models helped mitigate overfitting and maintain strong generalization. Here's a confusion matrix at a threshold of about 0.64, which I selected after sweeping through thresholds. This visualization shows how many loans were correctly classified and where mistakes occurred. False negatives are where applicants who default but were predicted safe are the biggest financial threat to lenders. They result in real monetary loss. False positives are applicants who would repay but were rejected, represent lost revenue, and possibly unhappy customers. Our most important goal is to reduce false negatives while keeping false positives at an acceptable level. The chosen threshold of around 0.64 strikes this balance very well from both an F1 and business risk perspective. This precision recall curve shows how precision and recall trade off at different thresholds. Default prediction is a classic imbalance problem, so PR curves are far more informative than ROC curves. I plotted the chosen threshold to show that it falls in a high recall, reasonably high precision region, which supports strong business decision making. If I had more time and more ability to improve, I would integrate external datasets, such as macroeconomic indicators like unemployment rates or interest rate trends, credit bureau scores like FICO, and market-level delinquency trends. These are widely used in real-world credit scoring and would likely improve predictive power. For monitoring their model over time, I would track model drift using metrics like Population Stability Index, or PSI, and measure monthly F1 trends and set a retraining schedule to maintain performance as lending conditions shift with constant changing world conditions. Overall, through careful preprocessing, XGBoost tuning, tenfold ensemble modeling, and threshold optimization, I was able to achieve a strong F1 score and a good ranking overall. Thank you for watching.